Okay, so we're going to go pretty fast through this. Last time I gave this talk, it was about 1 hour and 20 minutes. So we're going to go really, really fast. If you're watching this on YouTube, you might want to go at half speed rather than 2 times. In the room, if you can do that in your heads, that would be great. So why did I start to want to give this sort of talk? Now, OpenTelemetry has become kind of ubiquitous now. We've started to move from people wanting to know what OpenTelemetry is to, well, how do I actually use it? What are the things that I should be doing? What are the best practices? Why should I be using it in particular ways, et cetera, et cetera. So that's kind of why I saw this demand for people to know a little bit of practically how it should work. So, who am I? My name is Martin Thwaites. I go by martin.net on the Twitters and on Mastodon. I'm first and foremost an observability evangelist. I do lots of talks around operable software and supporting production systems. I'm also a developer advocate for a company called Honeycomb, who develops these kind of solutions on the back end, who are also an OpenTelemetry first company. So we only use OpenTelemetry for our ingest. I'm also a Microsoft MVP recently as well. So we'll start by looking a little bit about what OpenTelemetry is. I hope most people who've decided to come to a practical OTel talk know kind of what OTel is, but let's just assume that there are some people in the room for which this is a new topic. So, OpenTelemetry really is a protocol. At its heart, it's a protocol. It's the idea of how do I send telemetry from my application to a backend. It defines a format. It defines a protocol of how data should be transferred between those two. That is at the core of why OpenTelemetry is so popular right now, because it means that you don't have to choose vendors up front. Now, if you've been using things like iLogger, if you've been using loggers before iLogger came in, you'd know that when you start a project, the first thing you do is spend 6 months defining which logger library you're going to use, because then it gets prevalent throughout your entire software. When iLogger came along, all of that went to the wayside because, well, we don't need to think about that now. This is what OpenTelemetry provides, with tracing and with metrics, and ultimately it will be with logs as well. Now, they also provide SDKs for 11 different languages that allow you to implement OpenTelemetry. And by implementing OpenTelemetry, they have standards in the way that you define things like spans and span events and that kind of stuff. The current signals that they have, so these are signals, these are not pillars. Say that again, these are not the 3 pillars of observability. These are signals. There are traces. Traces are stable in, I think, all 11 languages right now, which is one signal. That's the signal we're going to be talking most about today. Metrics, mostly stable. I think there's about 50% of the languages who have a stable implementation of it. Whereas logs, the only thing that's stable is the protocol between the two systems. They haven't defined a standard of what the SDKs look like yet in any of the languages. It's highly likely that Python and .NET are going to be the standards of how that is laid out, though. So, what is a trace? It's kind of a thing, context, unit of work. There's not really what I would consider a good definition of what a trace is. But most importantly, it's not a thing that we create. We don't say, create trace. What we do is we create a trace ID. And we'll create spans that have that trace ID. Together, when you push them together, they make a trace. So a trace itself isn't something that we create. It consists of spans. Those spans can consist of some baggage when you're transmitting between systems. And all of those spans have attributes. Now, that's not a complete list. It's not a complete definition. I'm not here to repeat the spec of what OTel is for you. This is just to set the scene of what we're going to be talking about today. So what is a span? It's a structured blob of data. That's all it really is. But it has some mandatory items on it. It has a unique ID. We call it a span ID. It has a correlation ID. It's called a trace ID. It'll have a duration, how long that span took to execute. It'll have a timestamp, so when it started. And it'll have a causality ID. which is the thing that came before it that caused this execution to happen. And that causality ID is the really important thing when it comes to tracing. It's the really important thing when it comes to understanding production systems. Ultimately, it's really just a fancy log. If you think about a log, it's got some of those things already. We created a sticker for it. Stickers are available at the end. Okay, so what is a log? Well, when we're talking about logs in the context of OpenTelemetry, what is it we mean? It's a point-in-time action. It's something that only happens at that point in time with some arbitrary attributes. It's useful where context doesn't exist. So useful where we don't have a HTTP. It's useful where we don't have a message as our context to tag things to. So useful for things like access logs, audit logs, firewall logs, that kind of stuff. Not really useful for application debugging when you've got traces instead. Traces are much more powerful and do everything that a log can do. I mean, logs are mostly fine. Again, stickers are available at the end. Okay, so we're talking about .NET, we're talking about OpenTelemetry. How do we set things up? Now, I've spent a lot of time on the ergonomics of the OpenTelemetry .NET stuff. It should be really, really easy. Now, you will notice that we've got pre-release when we input these libraries. Specific reason, obviously logs, it's not stable yet, so we can't mark that as a release thing. But the setup is pretty easy. If you've been using things like Serilog, that kind of stuff before, you'll be familiar with adding something to the logger factory. That's as easy as it is. We say add OpenTelemetry and add an OTLP exporter. That means the OpenTelemetry line protocol exporter, which means we're going to be using that OpenTelemetry protocol between our application and the backend. That's the most basic implementation of doing it. By default, it's going to send it to localhost. I believe it's 4318 is the port, which is the default OTLP gRPC port. Metrics are stable in .NET because we had meter. We've had the meter class in diagnostics, so we're able to use that. So you notice that those don't. Plus, it's part of the core of OpenTelemetry. So add in a couple of packages, and if you're using DI, you can run add OpenTelemetry with metrics, and you can say, I want to monitor a particular named meter. We'll come on to what the meter names mean in a minute. But again, we're adding an OTLP exporter. We're telling it for these metrics. We're going to throw that over to the local host 4318. Tracing, again, very similar. Now, I've omitted here doing custom sources, because I'm going to talk about that in a minute. That itself won't do anything at all. It sets things up, but it doesn't do anything because nothing's being monitored. It's not monitoring any particular traces or tracers. So once you've done those, the other important thing to do is use the resource builder to tell OpenTelemetry what your service is called. Because if you don't, it's not going to know. It's going to use a DLL name. The default is unknown service : DLL name, which is not entirely helpful. So you can use that, configure resource. Just to be clear on the logs one on the right, I have included it, but because things aren't stable, things are changing. There is something much similar to the one on the left coming very soon for OpenTelemetry for .NET. But you need to set your resource stuff. That will set for every single span, it will say, I've got an attribute that says service.name equals that. Most backends will use that. It comes from something called the semantic conventions, which are defined by OpenTelemetry. Service.name is a mandatory property that has to exist. It allows the backends to assume that everything that comes from this particular service name means it came from that service. So I can group them together. That's why semantic conventions are really, really important. Now, the other thing we have is what's called resource level attributes. Now, resource level attributes apply to every span, exactly the same as what we were doing with the service name. They're defined when we do our startup. It applies to every log, every span, and every metric. Doesn't change based on those different metrics. They will all just be stamped with it. It's run at startup, so you can't do something that does it by request. It's applied asynchronously, So it doesn't affect performance of your application because it's applied when it gets sent to the back end, not while we're processing your span data. So those are some of the examples that you would put on there because they don't change per span. If you've got a service that's somehow transitioning between regions, between requests, and literally inside of your process, you've got a request that comes in and it goes, I don't know how you're doing it. Let's have a chat. But these are things that wouldn't change based on the process. But they're useful things to have. The importance of using tracing is providing more and more context, because the more context you have for every span, the more insights you can gain from why things go wrong, why things go right. So we can add the custom resource attributes like that. It's pretty simple, just a key value list. So you could, at the start of your application, go and grab the environment variables, call out to a metadata endpoint, grab all that data, add as many attributes as you want onto there, and it will be stamped on every single span that makes it outside of your application. Okay, so we've got the startup done. We'll start with metrics because we're going to touch on that just a little bit. So metrics are an interesting beast. There are very different types of metrics. There's a lot of math involved. I don't really understand how most of the math works. I don't think many people do. They just add them like, oh, it's a histogram with this. All right, great. But we define them in statics. You don't have to use statics, but they are useful to be done that way. And I'll come across the difference between dependency injection versus using statics for activity sources and metrics. But then what we've got to do is at the bottom, you can see where we've done diagnostic-config.meter.name. So we've defined a meter with a name. This one here is called our practical hotel BFF. That means back end for front end, not my best friend. We're then using that as the name of the meter, and then we're going to listen to that meter inside of our builder. That's as simple as setting up metrics is. What you can then do is anywhere in your application, especially if you've done this as a static, you can just hit record all over the place. OTel in the background is going to do all of the things like the intervals in which it's going to then compact this information and send it over. It's going to do all of that for you. You don't need to think about it. Now this code here, because this is using meter in .NET, there is no dependency on OpenTelemetry for that code. The only dependency that you've got is a dependency on the system.diagnostics library, which is really cool when you're writing libraries, because you don't need to depend on OpenTelemetry. Now, as much as I'm going to go into around metrics, they are a different beast. I don't particularly think they're as useful when we get to using tracing, but you can use them. You can use them for application metrics. And when we talk about the instrumentation libraries, a lot of the instrumentation libraries will also produce metrics as well. So you can follow the same approach for ASP.NET Core metrics or runtime metrics, all of those kind of things. So instrumentation libraries. These are provided by OpenTelemetry, sometimes by vendors, sometimes by the open source libraries that do things like Redis, or there's some for the hot chocolate stuff, GraphQL, that they provide instrumentation libraries which provide an opinionated way to monitor their particular libraries. And all it does is really set up some things inside of OpenTelemetry to say, go and listen to this thing. They're always language and SDK specific, because maybe there's a Redis one for .NET, but not a Redis one for something like Go. I don't know. Because they're all built by the individual communities. So don't expect to move between two languages and expect all of those things to just work exactly the same. What you can expect is the attributes to have the same names when they're output. Again, these are a lot of things coming from the semantic conventions that OpenTelemetry maintain. So in .NET, the most common would be SQL client, HTTP client, gRPC, HTTP. None of these you need to instrument yourself. You can add a couple of lines of code and they'll get there. Now, it's important to mention that these are only your step one. They'll get you a certain way there, These are what are going to replicate what you might have had with an APM before. They're opinionated. They treat every single application the same. They don't know about your context. They're not going to give you anything special. And your application is different to everyone else's. So these will get you so far, but it's important to go that step further. So for Microsoft, for most applications in Microsoft, you're probably using some kind of MS SQL or MPG or something like that, ASP.NET Core, and you're probably making some HTTP client requests. Those 3 lines in the middle there, add ASP.NET Core instrumentation, add SQL client, add HTTP client. That's all you need. That will get you a span for each HTTP request that comes into your application. Another span for every outbound HTTP request you get. Another span for every database call you make. And all of those will have standard attributes on them, like the route that came in. It'll have the DB statement that came in, that you used against the database. And all of those are defined by the semantic conventions. If you keep using these for the semantic conventions, what it means is your backends can make assumptions. It can make an assumption that db.statement will not contain PII, for instance, because it shouldn't. It's in the specification. It will if you actually write a db.command. These are all different attributes. So if you use these out of the box, you can feel safe that the vendors will know what to do with it. When I say vendors, that might be open source, like Jaeger, or it could be something else. Entity Framework Core does seem to be the new hotness now with all the performance improvements. So if you're using Entity Framework Core, you'll notice that this is pre-release. And if you notice on the one before, all of those are pre-release as well. And this is because the semantic conventions, the names, those standards, those haven't been ratified yet. They're very, very close. October. In October, with any luck, the HTTP and ASP.NET Core ones will become stable because the standards will be stable. The SQL client stuff is probably going to take a bit longer, but yes, they are coming. But until those become stable, we can't make them release packages, unfortunately. Entity Framework Core, again, is the same. MPG SQL, you'll notice the difference in how they're namespaced. MPG SQL is provided by MPG SQL. It's under their namespace, not under the OpenTelemetry namespace. They've marked it as stable. I don't think they should, because the names might change, but that's entirely up to them. You'll find anything under the OpenTelemetry namespace. If it doesn't have pre-release on it, we know it's stable. We're not going to change things. Redis is the same. The setup, though, is slightly different, because to do Redis, we actually need access to the connection multiplexer. So on that one, you've actually got to set it up slightly differently, which is using something called the configure method. So configure OpenTelemetry provides you access for a delegate to be able to have access to the service provider and the tracer provider builder, which means it doesn't run until the service provider builder has actually been started up. So you can have access to go and get some services and use those in your stuff. You can build your own like this. Just for Redis, that's how that one works. Okay. Manual. This is where the interesting stuff is. This is where your interesting context is going to end up in your telemetry. Because you know that algorithm. You know that bit in your code, that's the crown jewels that changes its performance based on different things. No auto-instrumentation library is going to get that for you. So, we talked a little bit about what a span was. And we need to talk a little bit about span and activity, because .NET has had spans for many years. We've had activity and activity source. So when OpenTelemetry defined the term span and started using the term span, I don't know whether span in .NET came first, but we didn't want to change it. So we're using the term activity. There is a shim that you can use to use the word span. I don't recommend it if you're a .NET developer. Just use activity and activity source. And if you're writing a library, definitely don't use that. Only use activity source, because it means you don't need to bring in a dependency. So when I use the word span and or activity interchangeably in this talk, I'm always talking about an OpenTelemetry span or an activity from activity source. So a span or an activity is about time-bound analysis. It's about I start something and I finish it. I would imagine that everybody in the room has tried to do a log entry, and they've started a stopwatch, ended a stopwatch, taken the time from the stopwatch, added it into a log entry, and said duration. Spans get that for free because we wrap them in and are disposable. That's what spans are all about. They also take in inbuilt context. So they take in, well, where did this come from? What was the initiating trace context? So it'll bring in correlation IDs. It'll bring in their parents. Bringing in their parents is what gives us causality. That allows us to see that this thing was caused by this other thing. And when you look at a trace waterfall, you can see which things ran in parallel. You can see which things were started by other things. You can see which service calls another service, which is really interesting when you first start doing tracing and you implement it across systems. And you get customers that are then looking at the system and going, your system's wrong. I'm like, what do you mean? It's like, well, it says this service calls this service. I'm like, the system just represents the data. It's like, yeah, but our system doesn't call that system. I'm like, I'm pretty sure it does. And then 2 weeks later, they come back and say, yeah, you were right. This is how you find those hidden things in your systems. So correlation being quite important. Now, the other thing is it's a scope of a piece of work. We talk about time-bound analysis, but it's also about scoping this particular piece of work and saying that this algorithm was the thing we ran. These were the inputs to the algorithm. These were the outputs to the algorithm. This is when it started. This is when it finished. So it's about that little bit of scope, which means that if you're measuring algorithms being my favorite example because they're the ones that change time, then it's really, really interesting. But yeah, it has everything that log has and more by default. So how do we manually create spans? Now, I wrote this little bit of code. I firmly believe this is how a lot of retailers do markup on their products, just run a random and add some markup to it. There's no instrumentation in here at all, but imagine that what we're doing here is that markup can change, the logic can change, the time it takes can change. Really good for a span. So first up, we create an activity source. Activity sources are keyed on name. Okay? So the name that you give an activity source, you can create 5 activity sources with the same name, and they will not be treated differently in OpenTelemetry, or in .NET for that matter. Because when we listen to an activity, we listen by name. We don't listen by object. So that's the reason why I prefer to use the static method. Because if I define that as static, I can access it anywhere and just create activities off the back of it. It makes my code quite simple because I just access the diagnostics config and the source and just start an activity. Now, the other way of doing it is using dependency injection. So you can develop a class. Now, it's important that you don't try and inject activity source into your class. Always create yourself a custom class that has your activity source in it. You don't necessarily need more than one activity source. If you want to, then great. But you don't need more than one activity source. You just need one in your application with a name. If you do that, then obviously you can inject that into your classes. Now, there is an idea that if you do this, it makes it better for unit testing. It really doesn't, because the activity source is the activity source. So you're not getting anything better from doing this, other than dogmatically applying different approaches of, let's dependency inject everything. And please, please, dear God, don't do iDiagnostic config as well and inject the interface so that you... Makes me sad. Okay, so we can now manually create our span. So this is the same class, but outside of our statement, our for loop, we're creating a span. We're creating an activity. And then on that activity, we're adding context to it. We're adding a product ID, we're adding a product price, the original price, and the markup. 3 different properties, giving them names. However, We're just using arbitrary strings at this point. That I wouldn't recommend. The reason I wouldn't recommend it is because having the same name in your backend across multiple different things, having that same common language in your backend observability solution means that you can make assumptions. So go and create yourself a constants class, which has all of those names in it. Create multiple constants classes to give them context. Because what that means is you can then go into your application and you can see all of those names. Now, the other thing you can do is you can use refactoring techniques to be able to say, go and find me everywhere that this particular property is used. It also means that you end up with a nice little dictionary of all of these things. You can add some XML doc to these to say why they're there. It means inside of your code, you've got a class like this. Now, if you are a cross-team company, you've got 5 or 6 different teams, you're writing microservices or distributed monoliths, or distributed monoliths and calling them microservices, whichever you're doing, it doesn't matter. If you're doing that kind of an approach, build yourself a shared library for cross-cutting concerns. So if product is a cross-cutting concern across those microservices, put it into a shared library that all it is a shared library of constants, which means that everybody starts using the same names, which means that when you start querying your data across multiple services in your observability backend, you can start joining up product IDs. You can say, is it always a particular product that's causing us performance problems? Is it always a particular customer that's causing us performance problems? It is always that one customer, isn't it? We all know who they are as well. Okay, now you can look at that and say, you know, this looks a little bit cleaner now because I can see what they've got as the names. I can also refactor the names easier. So I can refactor those variable names under the hood. I can call them something different. I can call them something really descriptive that isn't products.category.id. Now, the other thing I hate is when people create wrappers. So I create a wrapper around my activity source, and then I create a wrapper around the wrapper that I've just created for the activity source. And then the other team that implements that creates a wrapper around that wrapper to wrap the other thing that wraps the thing. You don't need to. Use extension methods. So write yourself some nice little extension methods to make things easier for your teams. Instead of saying, well, we have a particular way of implementing telemetry. So what we're going to do is we're going to create my company activity or my company span. And my company span has these methods on it. You don't need it. I would advise using out-of-the-box activity and adding extension methods that do common things that you want people to do in a particular way. Maybe you've got enrich activity with product. We'll write an extension method for activity that takes your product class and explodes that out and adds it as attributes onto your span. Do it that way. Don't try and write wrapper classes. Okay, so this is in the wrong order. So activity versus activity current. So because the way that activity works, when you do these two methods, they are subtly different. Let's see if this bit works. This bit isn't working. No, that's why, because it's that one. There we go. Right, so that there says start activity. That there says create activity. There are two different methods that we can use on activity to create one. Now, if we use start activity, it first creates an activity, and then it takes that activity and makes it the current activity that is running right now, which means that everything else that happens is a descendant from that activity. If I use create activity, all it does is create it. Now, in the first example, I could use activity.current, and that would work. And it did in the example that I didn't save. So if you imagine that top example has activity.current, that will add product and category ID to that calculate product markup name, the span that's created for that. It will add them to it, and that'll be fine. However, in the second example, it's going to add it to the parent of that span, not the span that you think it's going to add it to. 99 times out of 100, you are using start activity. Create activity is really useful in certain contexts, like async actions, that kind of stuff, but you don't need to do that. If you're using start activity, everything will just work. It'll be magical. But create activity is there. Just know that there's a difference between the two. And if you've got an idea around something that doesn't need to be the current activity, that exists. Go research it and find out whether it meets your needs. Now, activity.current is really good for adding context. Because when we use the ASP.NET Core instrumentation library, what we end up with is some default parameters. We don't get the query strings, for instance, as individual parameters. We get a URL that's about yay long. But what if the product ID was actually really interesting to you? Now, you don't have access to the span that ASP.NET Core creates, so you'd have to create your own span. With activity.current, you can access the current activity that is active. And then you can use that to append different attributes to it, like your product ID in this example, because it's part of what came in on the URL. Okay. Whew. So, span events. Span events are a point in time. Sounds a bit like a log, really, doesn't it? It's already got context because it's part of a span. So it's a point in time thing that happens inside of a span. Useful for things like exceptions, because exceptions happen inside of a span. Means it's attached to the span. It's basically a structured log with a span ID and a trace ID. It's not exactly that complicated. So a span event has similar properties that we were talking about before. It's not going to have a parent span ID. It's just going to have a span ID because it happened in this particular span. It had this particular timestamp. There's no duration on a span event, and that's how it differs. But basically, it's just a log. If you think of it like it's just a structured log that has those things on it, again, why would I use logs? Well, I've just add them to my spans instead, as span events. So how do we add them? So again, we're using activity.current here to add an event with some tags. In this particular example, it's because the validation failed, because we tried to add a product, it didn't have a product name, and we've added some error attributes that allow us to say, inside of our HTTP request, at this point here, it failed. Now, that might be interesting to you. You might want to set the parent span as failed as well. Now, you can do that when there's an exception. There's some inbuilt classes on activity to do that. So you can set the status. You can record the exception. You can pass it in some data as well. There are some helper methods for these things. Let's talk a little bit about span link. It's another type of thing that we can do with spans. So a span link is a casual link versus a causal link. Yes. I checked that about 4 times and I still thought I got it wrong. However, the idea is that a causal link says this thing caused that thing. A casual thing says these two things might be related. So there's not a dependency between these two. It's not saying that this thing was dependent on that thing happening. It's just giving you an idea that these two things might be related. So this is how we transition that trace context between two different systems, and then use that trace context to link other spans to it. That might be across process boundaries, like a HTTP request or a message, or it might be as simple as just inside of the same process. I've started a new process, and I want to be able to pass over some information to it, and use that as a new trace that could be linked. It is used most of the time as an alternative to parent and child. Some of the big examples of that is when you've got large-scale systems that have a unit of work, if you like, that spans multiple days and multiple services. And ultimately, that could be a 72-hour span that you see coming through. If you're using messaging systems and you pass something off for something to pick up the next day, you might want to know what the originating trace of that was. Take banking, for instance. Your transaction that somebody's done on their card, well, that's a trace, because that's a unit of work. That's something that's happened. However, when I charge interest on that transaction, that happens maybe a day later. Now, I may not want that to be part of the trace because it's not part of the action that's happening. But I might want to be able to get back and say, well, what caused this particular transaction to happen? I might want to be able to link back to the original trace. So here's an example of doing that. You can see on the top there, what we've actually done is taken out the current context, and then we've used that context to start a new activity in a new process, but we've not allowed it. So you can see where it says new activity context, so activity.kind internal, activity.kind internal, new activity context. New activity context allows us to say, create a new span, but ignore all parents. This one is going to be its own parent. It's going to be a new root span. However, I want you to link it back to that other span. You can have as many links as you want. You can say this particular thing has 5 or 6 different links. It's really useful for doing things like batch processing. You might want to link it back to the original span, plus also link it back to the batch execution as well. So you can do multiple links. Okay. Still with me? Makes one of us. So processors. So processors are part of OpenTelemetry. They're part of the OpenTelemetry pipeline inside of what you run inside your application. They run whenever we create or start a span. They also run at the end of every span. They do the same on logs as well. There's a processor for logs. It's going to allow you to do some interesting context. So you can run that at the end of every span. So as it goes to the end, go, great, I want to grab some additional data and add it to it, or I want to computate something and say, oh, well, maybe I want to add this to that and then add that as an attribute. Maybe I want to bring in the current weather. I don't know. So basically, it's your middleware. It's pretty much the same as a middleware for ASP.NET Core. So they look a little bit like this. These shouldn't be unfamiliar to people, the way that these work. It's just inheriting from a base. So what we can do, this particular one that I wrote, allows us to add the tenant ID. So the tenant ID coming in on a header, we can run that at the end or the start of every request. We can access the HTTP context accessor, grab the tenant ID out, and drop it in. Maybe this isn't the best example of it, but you can start to see some examples of why that might be interesting. Maybe it's bringing something in from some internal context. I don't know. Now, the important thing to know is that that will affect the inline performance of your application. Because when you dispose of an activity, you have to wait for the processor to finish. So if that's going to call out to a third-party service, you're going to have a problem. So you've got to be really careful about what ends up in there. Performance is a really big thing in OpenTelemetry. People have said, well, you know, observing my system, doesn't that make it slower? Yes, it does, by 200 nanoseconds per activity. Now, if you're optimizing on that scale, I don't think you should be using .NET. Just putting it out there. If you're going to put something in here that's going to take 2-3 seconds to process, yes, you are going to have problems, because every single activity that's created in your system that's being monitored, so every ASP.NET Core one, every database one, every Redis one, every single activity that's created is going to run that code. And you've got to decide whether that's the right place to put that. It might be, it might not. This is why there's a contrast between this and what we talked about at the start, which is the resource level attributes. Because if it's static data, use the resource level attributes, because those don't add that performance impact. So once we've done our processor, we use again that configure OpenTelemetry method, because we've got some dependency injection we want to do with the IHTTP context accessor. We can then add the processor like that. It's not complicated stuff. So let's talk about my favorite topic, which is baggage. It is the foot gun you never wanted. It is lethal. It should be removed, but it is there. Please use with caution is basically the message. I wrote an entire blog post on why it is evil. So baggage was built as part of the W3C trace context to provide context between your different applications, which allows you to influence the telemetry that's created. It is not an attribute that will appear on every span from there on out. You can make it do that, but that is not what baggage is. Baggage allows you to transmit some context between your services, and then in that descendant service, use that context to influence what will happen in telemetry. And W3C are the people to blame. Well, the people who submitted as a recommendation. So, why is it dangerous? If we add baggage, every external call that we make from our application will include baggage and our trace context. Now, if you can imagine what you might want to add onto baggage, I don't know, maybe you want to add the account ID so that the other services know what the account ID was from the originating request. You know when you make that call out to Stripe to do that, yeah, they're getting your account ID, your internal ones. You are leaking data at that point to your third parties. Fun story, a customer of ours at Honeycomb decided to put things like that on their outbound, didn't protect their outbound calls from removing that out. And what happened was we started getting all of their data on our API, and we hadn't protected our API from inbound baggage. So all of our spans were getting all these account IDs that we didn't. It's like, well, who's put account ID on the spans? We don't have account IDs. We have API keys. That's what we have. And it took us ages to find out. Is this one in particular customer that does it? It's the reason why there is a with public endpoint on the Go SDKs. It only exists on the Go SDKs because Honeycomb built it to solve our problem. But you can imagine if you're adding now loads of context inside of your baggage, every one of your external consumers is getting that. Do you trust every one of your external consumers? Do you trust the developers who work on your platform to know that if they add an external consumer, they need to start thinking about stripping headers? Okay, so now I've told you why not to use it. I'll show you how to use it. The other thing, by the way, that I hate about this is it's just a string. And yes, I have had somebody go, well, I need access to the person object in the other thing. I could use baggage. So they serialize the entire person object into a baggage attribute. Have you heard of view state? Why is my HTTP call 7 megabytes? When we set baggage, we access the baggage.current. Now, baggage, there is one inside of activity. It is not compliant with OTel. So that class that we're using there is part of OpenTelemetry. So in this particular example, we're going to take the account name out of our identity and pass it on the baggage. So when we make a call out to our stock API now, we've got some baggage. Then when we go into our stock API, we can now say, oh, this was a stock request for a VIP, because everybody should put those 2 lines in their code, by the way. Whenever you see Martin.net, put is VIP true. So we can use that to influence what attributes we do. Now, those 2 bits of code, neither of them add account underscore name as an attribute to any spans at all. It's where we get a lot of questions from people saying, I've added the baggage, but I can't see it in my back end, because baggage is nothing to do with your back end. What you can do, though, is you can write a processor. We just talked about processors. So at the end of every activity, we can say, well, go to the baggage.current, iterate over every one of them, and just add them as attributes. Great. Now, unless you protect your external public API, though, I could pass in baggage. I could just add a load of headers in my request to you and send in 20,000 different attributes. And all of a sudden, I've just added loads of performance impact onto your back end. That's not a good idea. What's a better idea is doing it a little bit more securely. Use yourself a prefix for your internal attributes for baggage. So use your company name, dot, whatever, so that when you're actually building these processes, you can say, well, only the ones that we know about. Use something obscure, something that's known internally, but not externally, that allows you to say, yes, this is actually something that we should be doing. It's a lot easier when it comes to things like messaging, because it's kind of hard for an external consumer to access your internal message bus. But from a HTTP perspective, it's a real problem, because I can blow out your observability solution by adding loads and loads of junk data into it from an external source if you don't protect yourself. So let's talk a little bit about custom propagations. The propagation that we've talked about so far is about how do we call a different system, like a different HTTP endpoint, and pass over the trace context, so that that new system inherits the same trace ID. It knows what the parent span ID is. Sometimes that doesn't exist. One of the places where it doesn't exist at the moment is in messaging, in a lot of the messaging libraries. There are solutions out there that do build in the trace context, but not all of them do, so you might need to do it yourself. The example I'm going to use is Azure Service Bus, because that doesn't happen automatically with the Azure Service Bus SDKs. And it probably never will because of batching. Because when you run a batch, it's hard to know which message you're running in the context of. So what do we talk about when we talk about propagation? It's trace context. So this is the idea of trace ID, span ID, and a third property, which is whether or not this span has been sampled or not. So is this a span that should be ignored? Or is this a trace that should be ignored? Which is really interesting when we come on to a little bit about sampling. Generally, if you're using HTTP, gRPC, you will get this out of the box. If you're using SQS, it is out of the box soon. It's about different process boundaries. If you're inside the same process, it's probably just going to work. So by process boundaries, we're talking about messaging, we're talking about HTTP, we're talking about .NET remoting, for instance. Not really a thing anymore, but you know, anything that goes outside of that current process boundary. So not just about a HTTP request. Now, the other thing that comes as part of propagation is baggage. Now, these are all generally part of headers, metadata. But what OpenTelemetry provides is the W3C trace context, which uses standardized names for all of these things. And that's what makes OpenTelemetry so powerful, because it means you can write in any language and assume that if you've got these particular names in your headers, you can use them. So what they provided was some libraries, some little methods for you to use. So instead of you doing this manually yourself and saying, right, well, I'll get the current trace ID, I'll add it into the trace state header, I'll format it in the right way, I'll call it the right names. You don't need to. What you do need to do, though, is provide it with a way for it to set them. So if you are using, say, as your service bus, you've got the application properties, which is a metadata property. You tell it, I want you to inject the current context, the activity.current that we talked about, and the baggage from current as well. I want you to take those two, and I want you to use this method at the bottom there to inject them into the message that I've passed you. And it tells it how to do it. Now that will go in and it will add any baggage it finds as individual properties. It will do the things like truncation. All of that stuff happens by default inside of that. You don't need to know about the names of all of those different headers. And then on the opposite side, you've got a similar method to extract them. Now we extract them and we get something called a propagation context. And the propagation context allows us to be able to take out the activity context, the baggage, all those things individually if we want them. But it will just set baggage for us. So again, the same sort of idea. We pass it the application properties. We could pass it message. And we give it a method that can act on that object to try and extract that data out. Once we've got those, we can then create our new activity, and we pass in that activity context. If you remember way back when we were talking about how we create spans without a parent, we were passing in new activity context. In this one, we're telling it what the parent is. We're telling it the parent is the context, the propagation context, activity context. So that will create as a new span. It will use the existing one as its parent. Okay, sampling. 8 minutes, right. And do questions after. Sampling is one of the key important parts of tracing. It's how it differs from logs, because sampling has two different parts. We can do head sampling, which happens at your application level. And we have tail sampling that happens after all of the spans have come through for a particular trace. It's how we retain full context of individual requests without overloading our backends. So it allows us to reduce our storage costs, means that we don't end up paying, I don't know, £65 million a year. Just throwing that number out there, no apparent reason. So what is head sampling? So it runs before spans are created. It runs before your root span is created. Why is that important? Well, it means it reduces our application overhead. Because if all of these spans that are being created now no longer are going to be recorded, it means our applications can essentially not do anything with them. But that means it's got very, very limited access to information. It doesn't know whether this is errored yet, because it happens right at the start. So because of that, we have very little information to go on. Tail sampling is way more complicated. So it runs on a delay after the trace has come through, normally part of a collector or some third-party service that you use inside of your data center or at a vendor. It has access to all the span data, though. Every single one of your spans. It has access to the status of all of those spans, the duration of all of those spans. It has downsides. Means we're delaying sending it to the back end. So if you want to wait, if your spans are generally taking 30 seconds to complete, it means you've got 30 seconds before we even think about starting to send those to the back end. But it requires the application to send all the spans, which means that there's no sampling in the front end at that point, which could be a problem for you. If you think about how spans are created, how data is transitioned between availability zones, network traffic, all of that kind of stuff, if you're working at scale, this can be a problem. So in .NET, you can write your own samplers. Please don't. It's hard. I don't understand it, and I've been doing this a while. But you can write your own samplers. This is a percentage sampler that will just randomly choose a percentage. If it's below a particular rate, and then it'll, yeah. It's not exactly complicated to write, but it is a thing. So finally, I want to talk about the OpenTelemetry collector. The OpenTelemetry collector is a service that OpenTelemetry provide. It runs normally in a Docker container. It's a Go library, a Go executable that you can run. But generally, people run it in a Docker container. It works as a proxy between your application and your backend. It can take in various different formats, one of them being OTLP. And it can output in various different formats, one of them being OTLP. But it has the ability to do processing in the middle of those, which is really interesting, because you can do some interesting things. So you can run it as a service. You can run it as a sidecar. It's a popular thing to run, especially if you're running things like Ruby, where you don't have asynchronous actions. But it allows you to have things like centralized config. It means that every single one of your applications doesn't need to know the API key for your backend. You can send everything through the collector, and the collector is the thing that knows what that config is. So from a security perspective, quite good. It also gives you centralized egress. If you're working in any sort of zero trust, any secure networking scenarios, your applications may not have access to the internet to send to your observability provider, but they will have access to send to something like a collector. It means you only have to ask the security team for one application. Generally makes that process go a lot quicker. But it also allows you to do things like filtering and redaction. Filter out properties. Remove PII from the data before it goes onto your third parties. It allows your platform engineering teams and your SREs to maintain this for you, so you don't accidentally do some of this stuff. But the other thing it does is things like enrichment. So if you're running inside Kubernetes, then you can run a collector inside of those scenarios, and it'll automatically add things like the pod name, the deployment name, from every span that comes through. So your application doesn't need to know about it. It's really, really interesting. I would massively encourage anybody in the room who's doing this at the moment, using OpenTelemetry, to bring the collector in. It might seem like it's a really big thing, a really complicated thing. It's really not. So it works on that. You've got inputs, you've got outputs, and you've got these things in the middle that do stuff that you want. There's loads of them. You can transform data, redact it, all that kind of stuff. I'm not going to go through those. That's not a specific .NET thing. And you can add things like that. Let's remove the health checks. I do advise everybody, filter out your health checks. They're not useful for traces. And if you're using Azure Front Door, it's chatty. Whew, we're done. That was a whistle-stop tour. I am doing a 2-day workshop on all of this stuff, and I've tried to condense as much as I can into a 1-hour talk. So if you're interested in it more, I'm doing a 2-day workshop at Copenhagen and a 2-day workshop in NDC Porto as well. So do come see me. We've got about 2 minutes for questions. Yeah.
So you mentioned not to write a lot on sampler, but you mentioned that it's like good built-in sampler.
Yes, so I mentioned not to write a sampler, but is there good built-in samplers? There are some samplers there. If you're running small-scale systems, yes, you could use those samplers. There is a tel-based sampler in the collector as well that you can use. I would generally stay away from sampling unless you're hitting really high levels, and if you're hitting really high levels, then think about tail sampling, not head sampling. That's why it's not really right to write them.
Is there a way to do head sampling if there happens something wrong later on the start?
So is it possible to do head sampling if something goes wrong later? No. Because the problem is you made that decision when the HTTP request came in. If in that process I've made a call to this service and this service, now I've already told this service that this is a non-sampled span, so discard it. This one fails. Well, I only end up getting this information and this one, and I miss that. So you're ending up with incomplete information, which is quite bad. So yeah, tail sampling is the only way to get all the errors. Or send all the data and spend 65 million quid a year. Any more questions? Feel free to come up to me afterwards. I'll dump some stickers out.